Hi, my name is Ivanna Yllahuaman, and the first thing I want to do in this presentation is ask you, have you ever used a Band-Aid before? I'm sure you had, but what's the problem with Band-Aids if we have used this uh, passive dressing for many, many years? That's actually the point. They are passive. They don't create a physical way to help your wounds to heal faster. They just protect your wound from viruses, bacteria, and any other um, component that might generate difficulties in this healing process. So that's what we wanted to solve through this research I was doing at Purdue, because we identify a big problem that is called chronic wounds. Chronic wounds does affect many, many people in around the world, around like 10 billion of people, and it does creates an economic burden of $22.5 billion only in the US. So this is a big problem. And the clinical challenge is that it's generally the treatment does include this passive healing as well, band-aids. But what we wanted to achieve during this research was to create an active healing dressing in order to activate some different pathways that are key, are really, really important to help in the wound healing process. What we wanted to use as a biophysical stimulation was magneto responsive elastomer that does create little vibrations, low frequency vibrations, and also electromagnetic field. So, how do we create this magnetic responsive elastomer? The methodology was divided in two. First, we designed the material. We used three candidates because we were not sure about what material we needed to put into this elastomer. So we used neodymium, iron particles, and carboline iron. Those three were mixed with the elastomer, and we create different samples. And we were also curious about alignment, so we use an external magnet to create the vertical and horizontal alignment. And the second part of the methodology was to know how much force output we were able to gain from these different samples. So we measured different distances, and with that magnet at different distances, we generate different force output to know which material was having the best result. The result of all this was that neodymium was the best candidate, and we were curious about, does the alignment of the particles inside the samples does really matters? And the answer was yes, it does matters, because we were able to see in the results that the vertical alignment had a really, really at what had the best result in all three combinations. So after that, we were sure about what material we needed to use and what alignment we needed to use. But the part I was having difficulties was the next one. I was in charge of creating the prototype, and the prototype one needed to be something as the size of a bandit. So I wanted to have the particles aligned vertical, but more vertically, maybe in a spike. So I had some difficulties creating the prototype because I needed to make a mold of these spikes, and I used acrylic and a laser cutter. I didn't have a lot of training on how to use a laser cutter, but I tried to watch some YouTube videos. I tried to learn by myself, and also knowing a little bit more about the parameters, because the laser cutter does require you to know the power you want to use, the speed, and also how big you want your spikes. Does really matter as well. So the curing time of this elastomer mixed with magnetic particles was also that was something I needed to take in consideration for this. So all this prototype making process was difficult for me because I was doing it all by myself. I didn't have much help of the PhD student I was working with because he was traveling. So I needed to figure it out how to solve all these variables that I didn't um, I didn't take on account before. So I tried to find out a way to solve it in learning by myself, and that is something I'm really proud of because I really made a good prototype thanks to that, and that's something I really like prove myself again. Like I want to prove that I'm capable enough to put my skills, to challenge my skills and to prove myself I'm able to do something I might think I'm not before being brave enough to try it. So that's what something I want to achieve through REPU. More research experience, I can prove my skills, I can challenge myself to do it and have good results as I always expect. Thank you.